We are in group 17. So under group 17, we are able to see the page? No?
We can see the page, ma'am.
Yes, ma'am. So under group 17, we are just seeing the preparation of HCl by the scientist Glauber. We are seeing the laboratory preparation. By heating common salt with the sulfuric acid at 420 Kelvin, you will be getting sodium bisulfate as well as HCl. So this reaction can be further proceeded with sodium bisulfate along with another molecule of sodium chloride in the temperature 823 Kelvin, resulting in disodium sulfate as well as HCl. So this is the laboratory preparation of hydrochloric acid. Moving to physical properties, it's a colorless pungent smelling gas. You can easily liquefy to colorless liquid. So boiling point is 189 Kelvin. Its freezing temperature is 159 Kelvin. So it's a colorless liquid. Upon freezing, it will be converted to a white crystalline solid. It is soluble in water and its ionization reaction. Since it is a compound, if you try to ionize it along with water, children, you are seeing the properties, yes, no?
Yes, ma'am.
Yes, ma'am.
But why, no? Generally, I used to get a message telling your screen is visible. Okay, fine. So it is soluble in water. It ionizes as HCl plus water, giving rise to H3O plus Cl minus. It's extremely soluble in water, so it ionizes to give you H plus 3O plus Cl minus. So you know any compound ionizes to give you an anion and a cation. So you got an anion as well as a cation. It reacts with ammonia. It gives white fumes of ammonium chloride. I think only the first two points will be coming under the physical property. The remaining is chemical property. Okay. So about its solubility, how it ionizes, and what is its reaction with ammonia, it's all your chemical property. This is an important point. When you try to mix 3 parts of concentrated HCl along 1 part of nitric acid, then you will be getting a new reagent. The new reagent is called as aqua regia. The main use of aqua regia is it is used to dissolve noble metals like gold, platinum, etc. So what is aqua regia? 3 parts of concentrated HCl and 1 part of nitric acid. So that is meant to dissolve noble gases. Then hydrochloric acid can decompose salts to weaker acid. Say for example, if you have taken sodium carbonate, it results into sodium chloride plus carbon dioxide plus water. Sodium bicarbonate give rise to sodium chloride, water, carbon dioxide. Disodium sulfate resulting in sodium chloride, water and sulfur dioxide. So hydrochloric acid decomposes salts of weaker acids like carbonates, hydrogen carbonates and sulfides. What is the use? It is used in the manufacture of chlorine, used to manufacture ammonium chloride and glucose. It can extract glue from bones. So what is this glue from bones is the connective tissue collagen can be isolated using your HCl. So that what is the main use of that collagen? It helps to decolorize the colored agent present in liquid. It is also used in purifying bone black. So bone black is otherwise called as bone char. When you heat the bones of animal tissues with a limited supply of oxygen, you will be getting bone char. I forgot the uses of bone char. Okay, I will just send a message. It is also used in medicine as well as a laboratory reagent. So these are about hydrochloric acid. Who want to sum up? No, I have a doubt whether I'm there or what. Yeah. Can anybody explain HCl, its preparation, its physical, chemical properties, etc.? Who want to try? Nobody wants to. Ansika, you want to try? Ananya, Bharathan,
Yes,
Krisha.
ma'am.
Before that, let me check the absentees. Who want to try? I will be sharing the page. Srinidhi present. Vibha is absent. Okay, Vibha absent. Then Sneha, Satvika, Deborah. Yes, present. Ananya. So Vibha, Lohit, Ravi, after a long time you have joined, right? So, okay, Vibha and Lohit. What about Srinidhi? I'm not able to see her. Srinidhi is also absent. Okay, Srinidhi. Fine. Three absentees. Yeah, tell me fast who want to
Yes,
sum
I
up?
want to.
Let's see. Yes, ma. Somebody told yes.
Yes. So HCl, that is hydrogen chloride, it was first prepared by Glauber in 1648 by heating common salt with concentrated sulfuric acid. Further, Davy in
Whether
1810
your
showed
voice is too feeble for me or to everyone.
Everyone, ma'am.
Ansika, little bit louder, ma.
sure ma'am.
Yeah.
Now?
Yes, Ansika.
Yes ma'am now?
Yeah, the same. It's the same. Little bit louder. It is so feeble.
Okay
I was
then.
just trying to increase my volume, but it is the maximum. Yeah, try. Try, Hansika.
Yes ma'am. Scientist Davy in 1810 showed that it is a compound of both hydrogen and chlorine. The
Mm,
preparation of HCl
mm,
in the laboratory, it is prepared by heating sodium chloride with concentrated sulfuric acid at
mm,
420 Kelvin, which yields NaHSO4 and hydrogen
mm,
chloride.
mm,
HCl gas, it can be dried by passing concentrated sulfuric acid.
mm.
Properties of hydrogen chloride: it is a colorless and a pungent smelling gas. It is easily liquefied to a colorless liquid at a boiling point of 189 Kelvin, and it freezes to a white crystalline solid with its freezing point being 159 Kelvin. It is extremely soluble in water, and it ionizes as H3O plus in
Mm.
aqueous and Cl minus aqueous. Its Ka value is 10 to the power of 7. In aqueous solution, it is called hydrochloric acid. The high value of the dissociation constant, that is Ka, indicates that it is a quite strong acid. In water, it reacts with ammonium to give white fumes of NH4Cl. When three parts of concentrated HCl and one part of concentrated HNO3 are mixed, aqua regia is formed, which is used for dissolving noble metals like gold and platinum. Hydrochloric acid, it decomposes salts of weaker acids, for example, carbonates and hydrogen carbonates. Its uses are in the manufacture of chlorine, NH4Cl, and glucose from cornstarch. It is used for extracting glue from the bones and for purifying bone black or bone tar, and it is used as an important medicine and a laboratory agent.
Okay, thank you, Ansika. So next, moving to interhalogen compounds. We are still in the chapter. What is interhalogen compounds? So you understood half from the heading. So it is from different halogens. So interhalogen compounds, halogens together forming a compound among themselves. So when two different halogens react with one another, interhalogen compounds are formed. How they are formed? They will be having this composition like chlorine bromine or chlorine tetrabromide or chlorine pentafluoride. You understood, right? So these are X refers to halogen. You have got two halogen. They both will be in monovalency here with tri, penta, then with hepta. See where this first X is referring to the halogen which is having a bigger size, and X dash refers to the halogen of smaller size. So we mean to say this is more electropositive than X. Which is the strongest halogen? The one which is more electronegative. Can anybody say?
Ma'am, fluorine?
Fluorine, yeah. So fluorine is most electronegative. So when I'm going to write fluorine as first one, then the second one should be less electronegative. Means I'm going to say it's electropositive than this electronegative fluorine. So they will be taking this order. Say for example, chlorine, fluorine, bromine, fluorine, bromine, chloride, iodide, bromide. So where the first part refers to the electronegative, the more electronegative element, the second one refers to the that is bigger size and the smaller size. See, this is X3 form, this is X5 form, and this is X7 form. How to prepare these interhalogen compounds? You can directly prepare. The interhalogen compounds can be prepared by directly combining the two halogens or by the action of halogen on a lower interhalogen compounds. So there are two ways by which interhalogen compounds can be prepared. One, you can directly combine them, or you can the action of halogen on lower interhalogen compounds. Let us see the example. The left hand side, this one, this chloride and fluoride, chlorine molecule and fluorine molecule in equal amount, resulting in the formation of chlorine fluoride. Here, this is formed by direct combination of two halogens, or the action of halogen on lower interhalogen compounds. I think there is no examples for the action of halogen on interhalogen. This is all is direct mixing only. Say for example, it will be, let me try one, ICl2 plus I resulting in ICl3. So action of halogen on lower interhalogen compounds. I said a rough example. So the first method, that is by direct combination, is almost all the example where directly the two halogens are combining, either both in equal amount, or when one compound is in excess, obviously the compound formed will also have that particular element in excess. There is one more way by which a halogen act on lower interhalogen compounds, resulting in the formation of interhalogen compounds. So when you look at these interhalogen compounds, they all are covalent molecules. They are diamagnetic in nature, means they have pair of electrons. So when you keep them in external magnetic field, they try to repel each other. They are volatile solids. They are volatile liquids at 298 Kelvin, except chlorine fluoride. This exists as gas. When you look into the physical properties, their physical property is in between the constituent halogen. Say, for example, if I want to know the melting point of chlorine fluorine, it will be intermediate of chlorine and fluorine, except the interhalogen compounds melting point and boiling point will be higher than expected. So say for example, chlorine will be having a melting point and fluorine will be having a melting point. But when you see as a compound, that is interhalogen compound, it will be little more than expected, and their reaction will be same. You can think of compound property to individual elements. Say for example, if I say water is a compound formed from the element hydrogen and water. What about the property of water? The property of water will be completely different from the property of individual element from where it is formed. Hydrogen is a supporter, oxygen is a supporter of combustion, but still water is an extinguisher. But when you check the interhalogen compounds here, their chemical reactions will be almost the same as that of your individual halogens. So interhalogen compounds are more reactive than normal halogens except fluorine. Why? So because the bond formed between two halogen, one is larger size and another one is smaller size, this is weaker except FF bond. That's the reason why they say interhalogen compounds are more reactive than halogen fluorine, because in fluorine the FF bond is stronger. Also, these interhalogen compounds undergo hydrolysis, so they give rise to halide ion and a hypohalite. So they undergo hydrolysis to give a halide ion and a hypohalite. So is all about your interhalogen compounds. So interhalogen compounds can be directly prepared by direct combination of two halogens or by the action of one halogen on lower interhalogen compounds. So can be prepared by direct combination both in equal amount or one in excess, then accordingly the compound will be formed. They are covalent, they are diamagnetic, they are volatile solid or liquid except CIF, which is a gas. So when you look into the physical property, it is in between the two halogens. Say I have mixed chlorine and fluorine and I've got a compound ClF. ClF's physical property will be intermediate between chlorine and fluorine. But when you think the melting and boiling point, it will be more than expected. Chemical reactions will be comparable. They are more reactive than individual halogens except fluorine because FF bond is stronger than XX dash bond. They undergo hydrolysis to give a smaller halogen, that is halide derived from a small halogen and a hypohalide. So these are the examples of interhalogen compounds, that is chlorine tetrafluoride, iodine. 7 means what? Heptafluoride. Then what is the uses of these interhalogen compounds? They are used as non-aqueous solvents. They are excellent fluorinating agents. ClF3 and BrF3, they are used to produce uranium hexafluoride, which is used in the enrichment of uranium 235. So which will be used in the nuclear reactors for fission and fusion reaction. Is it clear, children?
Yes, ma'am.
Oxo acids of halogen is there, ma. Let me check one time whether compounds of halogen. Yes, compounds. Oh yeah, oxo acids of halogen structure is there. It is there. So coming to the oxo acids of halogen, so you know halogens are electronegative, especially your fluorine is having high electronegative value and its size is comparably small compared to other halogen. So your fluorine alone forms one oxo acids while other halogens form numerous oxo acids. So the oxo acid formed by fluorine is fluoric acid or hypofluorous acid, while other halogens form many oxo acids. But you cannot isolate them in the pure state. They will be stable in aqueous solution or in the form of their salt. So what about the oxo acid of fluorine? How many oxo acids are formed by fluorine?
Only one, ma'am.
What is the name?
Fluoric acid. No.
Okay, hypofluoric acid, HOF, while all others will be forming many oxo acids, but not all of them are stable. They will be stable only in aqueous solution or in their salt form. Let us check the oxo acids of halogen formed by fluorine. It is hypofluorous acid. By chlorine, it is hypochlorous acid, chlorous acid, chloric acid, perchloric acid. From bromine, it is hypobromous acid, bromic acid, HBRO3. If you write it together, it will be easy. Then perbromic acid. From iodine, you got hypoiodous acid, iodic acid, periodic acid. It's periodic acid. Okay. So these are the oxo acids of halogen. So the structure of hypochlorous, chlorous, chloric, and perchloric acid. I think not much information about oxo acids. Whether much is given in the textbook? They have
No,
directly
ma'am. That's
skipped
it.
to group 18. Yeah, they have directly skipped to group 18. So moving to group 18 elements, HENA, something, some good acronym is there, right? नीना और करीना okay हीना नीना और करीना का एक्स-रे रंगीन. So helium, neon, argon, krypton, xenon, radon, these are group 18 elements, otherwise called as noble gases, because their configuration is ns2np6 with the exceptional fellow helium whose configuration is 1s2. These are called as noble gases. They are inert gases. Why they are inert? Why they show very less chemical reactivity? Because they are already stable fellows. Their configuration is completed with NS2 and NP6. They don't want to add an electron nor remove an electron to attain stability. So they don't want to participate in the chemical reaction. Still, some of the noble gases will participate in the chemical reaction. So all the noble gases are occurring in the atmosphere except the last one, radon. Its abundance, its atmospheric abundance in the air will be approximately 1% by volume, while majority will be occupied by argon. So helium and neon, they are also found in minerals of radioactive origin, pitchblende, monazite, and clevettite. The main source of helium is natural gas. Xenon and radon are rarest elements of the group. Radon can be obtained by the radioactive decay of radium. Okay. So, which is more abundant here in noble gases in group 18? Argon will be the most abundant, and rare will be xenon and radon are rare. They are obtained from the radioactive, I mean, radon is obtained from the radioactive decay of radium, element radium. So, all of them will be possessing the configuration NS2 and P6 except helium's configuration 1s2. Many of the properties of noble gases is showing their inertness because they have got completely filled shells. Physical property, because of the stable electronic configuration, their ionization enthalpy will be very high. But that decreases as you move down the group because the size of the atom increases. Okay. What is the first point? Ionization enthalpy. Because they are already stable, so it is very difficult to remove an electron. So ionization enthalpy will be very, very high. But as we tend to move down the group, it increases, it decreases. Why? Because atomic size increases. What about radii? Atomic radii also increases as we move down the group because size increases, atomic number increases, radii increases. And what about electron gain enthalpy? There is no need to accept electron because they are already stable. Therefore, they have large EGE positive value. So their EGE value will be more positive. What about the physical property? All the noble gases are monoatomic, not like nitrogen, oxygen. So, all fluorine, etc. These noble gases are monoatomic. They are colorless, odorless, tasteless. They are less soluble in water, less melting point, less boiling point because only one type of atom. So, here these elements are held together by weak dispersion forces, so less melting and less, I mean, low boiling and low melting point. Helium's boiling point is the lowest, it is 4.2 Kelvin. It has got an unusual property. It can diffuse through most commonly used lab equipments like rubber, glass, or plastics. Because of its lowest boiling point, it has the ability to diffuse through the commonly used lab equipments like rubber, glass, and plastic. Generally, all the laboratory equipments are made up of glass, especially borosilicate glass. It's called as borosil. The market name is borosil. Why? Because borosil will be inert to 99.9% of the chemicals. If you pour acid, strongest acid, weakest acid, almost all the chemicals will be inert. Not only to chemical, even the food grade substances which is stored in the glass, there is no reaction between your food substance as well as your glass. So that is most preferably used. But here, because of the low melting point, your helium will try to react, it try to diffuse through glass, plastic, as well as rubber. What about the chemical property? It is least reactive. Why they are reactive? Because they have completely filled configuration. Ionization enthalpy is high, EGE is positive. Compounds of inert gases, there are, we have told like it is mostly unreactive, but still few compounds will show reactivity. It is there: electronic configuration finished, occurrence finished, trend in physical and chemical property uses. Compounds of inert gas is not there in the textbook, right? It's not there in the syllabus. Can anybody check? Because I've checked it. It is shown introduction of group 18, configuration of 18. We have seen the occurrence. We have seen the physical property. We are yet to see with the chemical property. Compound, is there
Yes,
any
ma'am.
specific topic, ma? Compounds? No, no.
No, ma'am.
Okay, but still I will just have a highlight here because you want to know like which element of group 18 is undergoing chemical reaction. One second. Like how compounds were prepared from group 18. Like he tried to mix platinum hexafluoride with xenon and he got a complex compound like this. So colored compounds. Say for example, even your krypton is trying to react with fluorine, then radon has not isolated but only identified by means of radio tracer technique. So no true compound, this is the underlying point, no true compounds of argon, neon and helium are yet known. He tried, a few scientists have tried mixing your xenon with other halogens. Like see for example, xenon is mixed with the platinum hexafluoride to give a red color compound. So, see here also. He prepared one more red color compound which was formulated as platinum, hexafluoride is there, then a compound of oxygen is there, along with molecular oxygen. But still, very few compounds of noble gases were discovered. No true compounds for argon, neon, or helium is known. Why we didn't study about chemical property? Because it's chemically inert, so we are not dealing any chemical property for these noble gases. So the last part is uses. So under uses, helium is a light gas, it's non-inflammable. You know where it is used? It's used for filling balloons as well as for meteorological observation. It's also used in nuclear reactor as a coolant. And liquid helium is used as a cryogenic agent to carry out many experiments where you need to perform experiments at low temperature. So cryogenic agent means which is used at a temperature of minus 196. So helium is used as a coolant. It is used as a cryogenic reagent for experiments to be performed at low temperature. Then it is used to produce a powerful superconducting magnets which are used in nuclear magnetic resonance spectrometers as well as in MRI scan, that is magnetic resonance imaging, which are used for diagnosis, clinical diagnosis. So it is used to produce and sustain powerful superconducting magnets which are used in spectrophotometers, NMR spectrophotometers as well as MRI, which are used in clinical diagnosis. It is used as a diluent of oxygen in modern diving apparatus because it has got low solubility in the blood. What about neon? You know, no, neon light. Neon is used in discharge tube as well as in fluorescent bulbs for advertisement display purpose. Neon bulbs are used in greenhouses as well as in botanical garden. Argon is used to provide an inert atmosphere in case of metallurgic industry, in case of welding of metals or alloys. So it is used to provide high temperature which is used in metallurgical process. It is also used in laboratory to handle substances which are oxidizable. The substances which tend to oxidize upon reacting with air, for those substances your argon can be used. Not significant use for xenon and krypton. They are used for light bulbs which are designed for special purposes. So this is all about the uses of noble gases. Is it fine, children? So about noble gases, what important points you have to remember? You need to remember about high ionization enthalpy, then more electropositive EGE. They are inert, but still few compounds are discovered. No true compounds from argon, neon, and helium.
Yes, ma'am.
Not much uses from, yeah, not much uses from the last two. So I think we are done with the chapter. So tomorrow we every day we have a thing. So tomorrow, if you don't want to waste the 2 periods, what can we do tomorrow? Whether you want to do a recap of P block or shall we go for practicals
Ma'am, what
or
about the chemical properties?
which one, ma? Chemical? No chemical property for group 18 ma, because they are chemically inert. No, they are already having a filled configuration, so they don't want to participate in any reaction either to add on or to lose the electron. They are inert. Whether any reaction is given in the textbook?
Ma'am, here they have they have written about xenon fluorine compounds, xenon
Okay,
oxygen compounds.
so that is the thing which we have seen here. Is this the same point here? You mean to say compounds of inert gases, this one ma? Whether is this the points given? I'm also checking. Under chemical property, they have shown few properties.
Yes, ma'am.
Wait,
Some reactions are there, ma'am.
which one, ma? Few reactions are there.
Yes, ma'am.
Yes, ma'am.
Okay, Arya, can you share that page?
Yes,
Not
ma'am.
now, not now. Whenever you are free, you share the portion so that I can deal with that separately. See, one second. Yeah, I do, because I do remember, although they are chemically inert, they try to participate in few chemical reaction. You mean to say preparation of xenon fluoride is given? Xenon oxygen compound.
Yes, ma'am.
Okay. So preparation of xenon fluoride and xenon oxygen compound, yeah, it is there. Then structure of xenon compounds is there, ma?
Ma'am, you mean the linear, square, planar,
Ah, yeah,
distorted,
that one only.
octahedral? Yes, ma'am,
ZeOFO,
it's there.
ZeO3. Okay. Okay. So three topics are left out,
It's there,
which
ma'am.
I'll do it. Yeah. Tomorrow I will do it. So please think of the other option. After doing this, what shall we do? It's 40. What shall we do? Sum up of the same chapter? Anybody will be doing that?
Ma'am, after sum up, can we go ahead with the cation?
Okay, fine. So you want to finish off the practical first. Okay. After doing the remaining two topics, I will be sharing the PDF for this too. So after that, we'll move to cation practical. No? Okay, fine. Okay. So today again, I am checking. It is Vibha, Srinidhi, Lohit absent. That's all. But so many logged out, I guess. Okay. Okay, ma. Thank you.
Thank
Thank
you,
you,
ma'am.
ma'am.
Yeah, thank you. Ananya, Ananya, why are you? This is for class 11, no, Ananya. What happened? Whether I came back to the same meter? I'm sorry. Okay.